Andreas Bleuler is a senior software engineer in the team that develops Renku at the Swiss Data Science Center. He leads the industry adoption efforts for the Renku platform and is responsible for several educational activities at the center. Have you heard of Renku? If not, this will change in our next presentation. Andreas Bleuler will talk about this open source software platform that empowers data scientists to deliver reproducible and reusable analysis.
Thank you very much for this kind introduction. And first of all, I would like to take this opportunity to thank the SDS 2020 team and especially the technical staff for their flexibility, because I was supposed to deliver this presentation from the studio in Regensdorf, but I've developed, unfortunately, some very mild flu-like symptoms, and in the current time, it will not be responsible, I think, to travel by public transport still. So thanks for this flexibility on short notice. So with that being said, I would like to jump into my presentation and start to share my screen. I hope that you can now see my presentation. Perfect. All right, so welcome everybody to this presentation on Renku. That is happening from my home. And talking about home, these are the two homes of Renku, so the cities of Zurich and Lausanne, because Renku is developed at the SDSC, the Swiss Data Science Center. I believe that not everybody is familiar with the SDSC, so just one slide about it. The SDSC is about 3.5 years old. It was funded on an initiative of the ETH board, and it's implemented as a joint venture between the EPFL and ETH Zurich. And we were tasked with the following mission. The center's mission is to accelerate the use of data science and machine learning techniques within academic disciplines of the ETH domain, the Swiss academic community at large, and the industrial sector. So the emphasis here really is on the word use. And as you can see, it's a pretty broad mission. So what do we actually do to live up to that mission and to that task? So we collaborate with academic groups on their domain research problems. Similarly, we help companies. We collaborate with companies to help them with their data-related challenges. And finally, and for today, most importantly, we develop technical solutions to advance the adoption of best practices in the field in general. And the flagship here is our platform, Renku. So just a few words about myself to give you some idea about my background. So I'm a theoretical astrophysicist by training. I'm also the co-founder of a startup that, let's say, did not exactly go through the roof. And nowadays I work as a senior computer scientist and act as industry liaison for the German-speaking part of Switzerland at the Swiss Data Science Center. So, as I've just said, in a previous life I was an astronomer. And what I did is I ran large-scale HPC, so high-performance computing simulations, about how stars form in our galaxy. And so I was running those large simulations on infrastructure like the Swiss Supercomputing Center, and then I was taking these simulations as outputs, as kind of my data source, and was then post-processing this data to produce plots and figures and finally publications. And if I look back at this process now, I realize a few things, and not all of those realizations are very pleasant. So first of all, I realized that I could not reproduce my own results today. So why is that? The problem is that all my code, all my simulation code, and even the simulation outputs, they're probably still available, lie around on some server, but I simply don't know what exactly the procedural steps were that I executed, and which version, which parameter set I use for a simulation, which version of simulation code I apply to get a certain simulation output, which versions of analysis routines I then apply to that, to finally arrive at a figure that was then published. Also, I realized that there's probably a younger version of myself sitting on my previous desk and reinventing some of the things that I have already written. So why is that? So first of all, I think everybody can relate to that. What you believe to be a one-off, especially in the kind of post-processing, let's say a routine to produce a script, is not given the same attention for documentation and stuff as probably your big code. So it's something that you believe you will need only once, and then you just take care of it until it runs, but you don't document it, you don't publish it, not to speak. And another problem with code is that I might have been using libraries that have been deprecated or libraries where the APIs have changed. So even if this younger PhD student found my code, it would probably just not even run and break. So it's probably easier for this person to just rewrite the code. Similarly, I mean, I burned quite some CPU hours, worth probably in the 100,000s of Swiss francs. And not all of those results would be reusable. Some of them are probably simply trash, but some of those results could definitely be reanalyzed in a different context. But it's not happening. And I would argue that even if I had made those results available on a platform like Zenodo or Figshare, and even if I had added some metadata, which I mean, I didn't do neither of those two things, but even if I had done that, it would be hard to reuse this data without seeing the computational steps that led to this data, and without seeing some example usage of this data. So without seeing an example post-processing pipeline of mine. And without those two aspects, I believe it's very hard to just reuse and also trust data that you just find on some data repository. And finally, collaboration could also have been more efficient, particularly with my PhD advisor during my PhD time. There was a lot of forth and back sending of emails, screenshots about plots and what I should improve. And this would have been much, much simpler if my PhD advisor could have just dropped himself into my computational environment. But of course, it was too much to ask from him to have the computational environments of 5 PhD students, 3 postdocs, and some external collaborators all replicated on his laptop. So therefore, just sending forth and back of screenshots. But a solution, a technical solution allowing him to just modify my analysis code and quickly improve some of my plots would have been of huge value. So after going into my past and do some soul searching, I think it becomes obvious what the goals are that we're trying to solve with Renku. So goal number 1 is we try to achieve computational reproducibility of results. Goal number 2 is we try to achieve reusability of both code and data. And goal number 3, we try to improve the ease of collaboration. The good news is we're not the first ones to think about that. Many of these individual aspects are already solved by existing open source projects. So I would be tempted to go and say, it's easy to do better than I did during my research time. Just follow this best practice guide. Use version control for all your code and data. Then keep track of all the operational steps of your analysis, ideally in some kind of workflow definition language to be portable, but even a bash script that you will put under version control or some Python script is better than just trying to remember what exactly you did several months in the future. And finally, always provide a runtime environment, so always provide a Docker image that provides a runtime environment for your code, for your analysis to run in. And then, of course, keep the description of those runtime environments. So the Docker files that describe those Docker images, keep them under version control as well. it's fair to say that this is a pretty steep learning curve, and I think we can't ask every new scientist or new data scientist starting a job to first gain experience as a software engineer for 2-3 years before starting to do what they really want to do. So we try to make the life a bit easier and say, just use Renku, which our goal is to try to make it simple for people to follow, to adhere to those best practices without the need for a career in software engineering first. Of course, we're not starting from scratch. We're leveraging a lot of open source projects. I'm not going through that list here in the interest of time, but it's just you might recognize one or the other logo that could give you an idea of the space we're operating in. So this is the point where I would usually start a demo, but with the complexity of the technical setup that we already have today, I think this might be a recipe for disaster. So instead, I just share some screenshots with you, and I hope that this will give you an idea about the Renku project still and how it looks. So Renku has like two interfaces, Web UI and the command line interface. So the Web UI has the landing page of the project. Oh, looks like this, and you can actually go and check out this project on the link. It's publicly available on the link that I've added to this slide. What this project does is not of primary interest here, but we can have a look at the content of this project. So a Renku project is really just a Git project with some bells and whistles. So we add some initial structure that we believe is useful. So a README file for a Python project, a notebooks directory, because people like to use notebooks. We also have a data folder. If you've learned that you shouldn't put your data into Git, yes, but we use a technology called Git LFS, which allows you to exactly do that without breaking your repository. We have some other things in here that we provide by default. It's a Docker file and an environment.yaml file, for example, or a requirements file. So those are basically the cooking recipe for this computational environment that your code needs to run in. Usually users don't have to manipulate that, at least not the Docker file. If I want to, let's say I want to add a Python package, I would just add this to a requirements.txt file and push these changes back to the server and not modify the Docker file, because some people might find this a bit daunting. And then finally, there's a file which is also pre-configured. Users usually don't need to modify it, but it's important because this gitlab.ci file, it kicks off. So if I go and modify the requirements file to install, say, another Python package, and I push this back to the server, this gitlab.ci file will make sure that the pipeline is kicked off that will actually build this Docker image and make then the new, the updated computational environment available for me or for my collaborators to use. Per default, we always include a JuptyerLab or an Rstudio server in those environments, and this allows us to bring up some interactive environments for the users in a web-hosted way. So you can choose your version, your branch, and pick some other parameters, and then start a new environment and immediately drop yourself into this environment that I've described before. Then the interface that people usually work with is a pretty standard JuptyerLab or Rstudio interface, but the difference is everything you need is already there. So admittedly, this is more exciting when I execute actually this code and the cells, but the dependencies are there, my code is there, my data is there, and plots like this one will just happen out of the box. And I think everyone who has banged his or her head against the wall for a while trying to get someone else's project to run will appreciate that. This also holds true for more complex setups, let's say where you have a CUDA driver for TensorFlow. If it runs for me, it will run for someone else. The second interface is the Renku command line interface, and I want to mention only one use case for that, which is the recording and the rerunning of workflows. So imagine you have some Python script called some script that takes two data files as inputs, some data and other data, and I would usually run it like that. Then I can just prepend Renku run and execute it like that. And what happens now is that Renku will track this step for you and will track the fact that some data and other data have been input to some script, and this has produced a certain output. It will just track the output of this step. And if later on I add some new lines to some data.csv and I want to update my results, I can simply do Renku update in the project, and Renku will go and actually update not just the result that I've computed in this step, but I might have used this result as an input for other steps. So it will basically look at the entire dependency graph and update all results further down the line. So this dependency graph that I've described, or this pipeline that comes together, that's actually, this dependency graph annotated with some metadata is what we call the knowledge graph. And I think the best kind of one-sentence description or one-liner that I can give for the Renku knowledge graph is you have to imagine it as a searchable index of all your data together with some description of the processes interlinking the data. So this is probably the fundamental concept of Renku, that you combine data with the processes interlinking that data, and that those processes, that you capture them in a way that they're automatically re-executed. Once you have this knowledge graph, it allows for pretty cool queries. You can look at some data and you can wonder, oh, what results have been derived from it. Or you can go and you can search for an algorithm. Say you found a bug in your code and you want to find out which results, which reports might be faulty and might have to be redone. Or finally, you can look at some result and do a query to obtain the entire lineage and to find out who deserves a pay raise. So this knowledge graph, this enables all those things. So I'm already at a point where I should start wrapping up. So I know that I've touched many things and it's sometimes a bit tricky to grasp the entire scope of Renku. So what I want you to take away is this. Renku is an open source, self-hostable platform integrating Git, Jupyter and Rstudio, Docker with analysis workflows, and the whole thing is linked with a knowledge graph. So I have some time to go into the current status of the project. That's great. Development started in early 2018. We have a public deployment. The link was also in the title slide. It nowadays has about 1,300 registered users. It's the COVID time has actually been quite a boost in terms of users, as many courses have moved online. So many people have found this, especially those shared environments, very useful. Our goal is this. RenkuLab.io is open for the entire world and free to use, but we don't have resources. If the usage picks up like crazy, we don't have resources to provide for the entire world. So our goal is not to just have RenkuLab, but our goal is to have, as I said, to provide a self-hostable platform. And so institutional deployments are either already up or on the way at Swiss universities, but also particularly at the East Coast in the US. Another very exciting development is that we have just brought up a dedicated deployment for the Swiss COVID-19 task force that they're starting to use these days. We also have one deployment with an industrial partner. You have noticed, I'm sure, our primary focus so far has been on the academic side, but from countless interactions, I know that companies are suffering from exactly the same problems And it's not at all our intent to keep Renku a platform only for academia. How is Renku used? Maybe one very interesting aspect that I would like to highlight here that has actually picked up massively recently is the teaching of zero setup courses. I've been using that myself in a course that I teach. It is extremely convenient to just provide users with an environment, or your students with an environment where they can drop themselves into your configured environment without sending out any long emails of setup instructions before they can actually start the course. I'm going to skip the rest and just go to the development focus and the outlook. So Renku is still under very active development. Our current focus areas are clearly the workflows. They are there, but they're not always as easy to record as we want them to be. And we also want to provide some means of online executions of workflows so that this can happen, that you can just kick off a pipeline that will re-execute all the necessary steps to recompute the result and just basically go home, and the next morning will be done. We're working hard on the dataset abstraction. So far, we're using this Git LFS platform as a primary data backend, but we are aware that be it object stores or even databases as different data backends, that this is a must-have, and we're trying to achieve this by having a very flexible dataset abstraction. And finally, we want to better leverage this knowledge graph that we're building, and also we're working hard on making the deployment process as easy as possible, so that others can really jump on the project and deploy their own version of Renku. That will be it. That's my last slide. You will also find this in the PDFs later on. So I think I will stop the screen sharing at this point and go back to the studio view. Yes.
Thank you, Andreas. And we do have a couple of questions, so let's see how many of them we can tackle.
Great.
How do you deal with security and data policies? In most experiments, data are available only to the members of collaboration.
Yes. So it really depends on the data backend, as I've said. So far, Git LFS is our primary data backend. So basically, the data inherits the access policies from the GitLab project. So we're always running a GitLab instance in the back of Renku, or the GitLab instance is a part of Renku. And you can set access rights to a project, and then the data will get the same access rights, basically the same access policy that your code in the project also has. It clearly has to be said that Renku is a platform that is designed for open science. So for use cases like this COVID task force instance, we just limit access to the platform entirely to collaborators.
Mm-hmm. Software engineering best practices are important for running applications in production, okay. Even for a data scientist, wouldn't Renku discourage such best practices?
Discourage,
yes.
I would argue that encourages best practices by basically making it easier to adhere to them. Because in the end, I mean, what you're left with is just a well-executed and well-documented project. You have your code, you have a Docker file for your code to run in, and it's a Git repository. I mean, you can take it anywhere from Renku. There's no such thing as a vendor lock-in. And I would definitely argue that it, also by providing reasonable templates, I would definitely argue that it encourages the adherence to best practices.
Andreas, thank you for joining us today, even if only remotely, and I hope you get well soon.
Thank you very much.
Bye-bye.